Thank you everyone for joining us this afternoon on this webinar. So again, this is one of our monthly webinars on infrastructure with a focus on roads, highways, bridges, and tunnels. So today I'll take you through on an interoperability between Civil 3D and Revit using BIM 360 to basically share topography information, but just basically the site design. So the site design cuts across different disciplines. That's basically an architect who may require topographic information from a surveyor or a civil engineer. Or also sometimes the surveyor and the civil engineer can also communicate site information to the structural engineer who is doing a bridge in Revit. So that's basically what we are going to look at today. So having been introduced, I will also have a short slide just to also recap on myself. So I work with ID Technologies as an applications engineer, mainly focusing on the infrastructure side of the business. So I'm an experienced civil engineer here in Kenya with a very big interest on BIM for infrastructure. So I'm also a member of the Institution of Engineers of Kenya, working here locally also. So as I said, we are going to look at how we can share topographical information between Civil 3D and Revit. And also topography information can be originated from InfraWorks. Then you develop it further into Civil 3D, after which you can share it into Revit. So as I said also, so this basically looks at topographic site information for building or for a bridge. So meaning that for a detailed design of a structural bridge, you basically also need to give topo surface, which will be used by the structural engineer in terms of confirming the levels, maybe the depth of the foundation below the ground, just to confirm things like the headroom for the traffic. Okay, so basically that's what we are going to look at. So we'll start by a very brief introduction to basically highlight what we are looking at today. So in terms of the software that we focus on today, basically the focus is on Revit, Civil 3D, and InfraWorks, both of which will be sharing the information from one to another via BIM 360. So these are the sample surfaces that you are looking at. So it can be a building pad. It can be an overall site plan, basically showing like the parking areas around the building or the building site in terms of the driveways and on any other related component of a site. But in terms of the bridge also, as I mentioned, we may be interested in knowing, like if you're doing our piers or our abutments, how deep below the ground does the pier go? And how deep below the ground are we going to lay our foundations? And then also in terms of confirming the headrooms for the traffic, also forms a very important part when you need to generate structural bridge design. So currently, we know that these are being done in different manual ways, but if you can maybe adopt this kind of a workflow that we're going to illustrate today, it will make your work easier in terms of sharing such site information or topographic information between the civil engineer and the structural engineer, or the civil engineer and the architect who's interested in doing their building site in Revit. So basically, if you can see on the right-hand side of that, basically that's what you're talking about. You're having your architectural model, but how do you now integrate it on the site? Because the contextual design is something is really gaining popularity in the AEC industry. So instead of just coming up with a DWG or CAD file that you create there, you can easily import the information with the exact level from the topo surface that on which that particular building is going to be done. So for the few who might have worked with Revit before to do topographic or just site design, they could have been using an existing workflow which basically incorporates linking of a CAD file from within your computer. So the only difference that you're going to look at today is instead of just having it sitting on your computer, it can sit somewhere in the cloud, because in many cases, not the architect and the civil engineers sit in the same office. They sit sometimes in very different geographical locations. So instead of doing that manually by sending mails or making several calls to receive that site information from the surveyor or the engineer, we look at a platform where you share that topographic data within a cloud platform, and therefore the whoever is interested in working with it will automatically be receiving it and even automatically receiving updates at any particular time the design change is made by either the civil engineer or the surveyor. So the key advantage of using this workflow I'm going to illustrate is basically, as I mentioned, that the changes in the topo surface data in Civil 3D is automatically received in Revit, and the previous workflow, as I mentioned, does not automatically allow you to receive updates in terms of which changes in terms of the site that the engineer have made, maybe the new link roads that have been done within that particular site plan you're working on. It doesn't keep you up to date. You need to always be requesting for such changes or calling for a number of site review meetings to be able to get up to date. But in this case, the changes will automatically be received as I'll be illustrating in a live demo. So if it's for a bridge, this is the basic workflow for a bridge where we do the conceptual bridge in InfraWorks. Then if you have to customize it further, you will maybe need things like another software like Inventor to do specific shape customization. Then you can now share the topography or the surface with Civil 3D when doing the detailed design for the road on which that bridge is carrying, or even further with Navisworks. But to do the detailed structural design of the bridge, as I mentioned, you basically need to do it in Revit. So meaning that Revit also need to communicate with these two previous software. That is, in AutoCAD Civil 3D, you do the detailed design of the surface, plus the concept that you created from InfraWorks. So once the structural engineer has received his conceptual structural bridge model in Civil 3D, in Revit, sorry, they need a communication from either the surveyor or the roads or highways engineer to communicate to them in terms of the confirmed road levels that they should now use to establish the different bridge levels in terms of maybe the top, the edge, the center line of the bridge, the two edges of the carriageway that the bridge is carrying, what are the exact elevations, and is in terms of the levels for the piers, levels for the abutments. They now need to receive that topographic information and work with it also within Revit interface, because it's in Revit interface that the detailed design will be generated. So we're looking at something which looks like this. So I know as of now, most of us still either works with AutoCAD in terms of generating this, which I'm very sure usually takes you quite a very long time. But if you'd see basically how easy it is in terms of once you have received that topographic information from the engineer and you link it up into your Revit, you'll find proceeding with the producing such level of detail now becomes very, very easy. But before I go further, so since this basically is going to happen, the sharing of that topographic information happens between the two softwares using BIM 360. There are a number of different BIM 360 products, but the one that will enable us to do this is basically the BIM 360 Docs, which has a way of automatically controlling the publishing, viewing, and sharing of the information. And it has in it a way of controlling the documents plus even the versions that you're working on. So that is like, if you have been receiving several updates, it can automatically help you know which version are you up to date, or are you still working on maybe a version which was last shared maybe like 2 weeks ago. You can easily perform design reviews with it, and both in 2D or 3D, and easily manage your documentations just in a summary. So the product that you're going to use to link these two different desktop software is the BIM 360 Docs, but there are a number of BIM 360 products from Autodesk with different functionality, but I will not go into details in each of them. So just basically look at how you can access that site information from BIM 360 Docs and send it from Civil 3D into Revit. So as of now, I will not ask question now, but I'll just go into the software. So I'll just share another screen, sorry, so that you'll be able to see what I'm talking about today. So as I said, we basically start from InfraWorks. So if you can't see my InfraWorks interface right now, just confirm with me so that I can check on why. So basically this is the bridge I'm looking at today. So we have a very good conceptual bridge which has been designed. So we have all the structural analysis in place. So what's remaining is for us to send that topographic information into Revit so that we can start producing the relevant details that can be used for actual construction. So this is the bridge. So if this is the bridge that you have with all the structural elements that have been confirmed to conform with the different design requirements, you just need to send it into Revit by selecting that bridge, right-clicking, and you go down and say either open it in Revit, that is if it's already an existing Revit model. So like in this case, the one I'm having is already an existing Revit model. Or if you need to make a change, meaning that there is some updates which I've made within InfraWorks that I need to send into Revit to update it, I'll just say update the existing, or I'll start by creating a new one if the first time I'm doing this. So you can see here I'm having plus even the topo surface. So basically it's a topo plus an imagery on top of it, but I'm only interested in sharing that topographic information into Revit. So the topo can come from different sources. When you have worked with the InfraWorks before, it could be from different data sources, which I want to go into details, but basically like it could be from maybe a DGN, it could be land XML, it could be a point cloud, it could be a raster, or it could even be an existing WG file from which you created the surface and imported it into InfraWorks. So that's not for the topic for today, but the way to start off, I'll export it in our InfraWorks file format that is referred to as IMX. So I'm assuming all my work started from InfraWorks, but some people could directly also start from Civil 3D to share that service directly into Revit. But so in my case, I'm having everything started from InfraWorks, and you can see it is context-based. So I'll export it into what we call IMX. So IMX basically allows me to choose a specific component of the model, and you can see it's also georeferenced, meaning that I have to choose a specific target coordinate that I want it to be exported to. So then I can just choose the small area of focus. So that's just the area whose topography I'm interested, whose information I'm interested in sending into Revit via Civil 3D. So once I've chosen it there, I just need to choose the file path. That's where I want to save it to. Then I'll just click export. So click export, it takes a few seconds. So at this point, again, just note that I'm saying my bridge has been sent into Revit. So what's remaining is the surface, the topo surface. And you just need to note that it's a dual carriageway, plus also, there's also 2 rail tracks on this particular side here of the bridge. So that my bridge is currently in Revit now. So what I'm missing in Revit, so maybe if I can just share Revit, we have a preview of it. So this is the bridge which I've sent into Revit. So remember, Revit is purely structural, architectural, and MEP. So that's why the topo does not automatically come into it. So this is the bridge. I've only sent the abutment, the piers, the girders, the deck, and any related structural component. So what I'm missing right now, if I were to start producing the details of this, I would be limited in that I'm only having the plan view. I can have different sectional views and even the 3D of my bridge, but I can't basically see what levels are we working with in terms of when I'm looking at maybe just the overall elevations for the deck in terms of at the 2 edges of the carriageway and at the center of the carriageway. And maybe also what's the overall elevation for even for the abutment. So those information are what you're now going to extract from the topo surface that we are going to bring into Revit via Civil 3D and BIM 360. So I will now go into Civil 3D. So I will share my Civil 3D to see that so that you can have a look at that topo. So I'll open Civil 3D. Again, so again, just confirm with me that you can see my Civil 3D. So the process, so I've gone one step ahead here because it would maybe takes 1 or 2 minutes of our time. So to bring that InfraWorks topo surface into Civil 3D, you can see when in Civil 3D, you have a specific tab dedicated for InfraWorks. Basically, it's the tab that you use to extract InfraWorks information and use them within Civil 3D interface, meaning that basically it allows you to do direct interoperability between Civil 3D and InfraWorks. So for example, if I wanted to bring that IMX file, which has the topo surface information from InfraWorks into Civil 3D, I basically click on import IMX here. That's after having gone to this tab for InfraWorks here. I'll just click on import. Then it will allow me to search for the path where that particular file is. So like it could be any of these ones. So you could have as many IMX. So basically the number would vary based on maybe the number of topographic information you want to extract. But in this case, I'm only interested in the one which was giving me the bridge. So then I'll just click to open it. So again, I'll not click to open because it's the same information which I've already clicked to open here. And that's what I'm having within my Civil 3D model right now. So it's the IMX file which I use. So I'll just cancel in this case. So as you can see here, this is the topo surface that I have, basically showing me both the existing, the finished, or even the proposed. So if you have worked with one before, you basically know the process of creating a topo surface within Civil 3D itself usually takes you also a number of stages. But in this case, if you bring it from InfraWorks, based on the style that you have, you will automatically receive it within your model, and you can even have a preview of it in terms of just basically trying to understand how does the existing elevation or model compares with the one that you are proposing. But again, since in Civil 3D, again, it's not easy to have that better conceptual view as you would see it in InfraWorks. That's why it is still easy again to send it into Revit. You basically have how does that various bridge component fit in within the existing and proposed surface. So within Civil 3D, we can basically just see the proposed bridge component in terms of maybe how does it go across the road, in terms of maybe the overall fitting in within that topo surface that we're working with. But we can't add more details unless we have to plot a profile view for the same, which, as I said, is similar with it's more like similar with what we use in AutoCAD. So that's why if you'll be able to go through the work that we said, instead of working with it within Civil 3D here, just send that topography surface into Revit, then you are going to see how easy it is to work with it. So if you want to send that topographic surface into Revit, I said we use BIM 360. So BIM 360 is a cloud platform. So basically meaning that it's more like you would require an internet to access it, the same way maybe you'd access your email or Gmail account. That's basically what BIM 360 looks like, but I want to go deep into it as of now. So I'll basically show how you can send this surface into BIM 360. So meaning that at this point you must have BIM 360 account and you must have created a project. So if I can just go to BIM 360 again to give you an illustrative view of what we have there. So shortly I'll just go on to the BIM 360 so that we can have a look. Just bear with me for a minute. Should be this one. Let's share that screen. Share. Okay, sorry. So this is the BIM 360 that I'm talking about. So I'm already having a number of different topo surfaces being uploaded up there. But the way it works, it allows you to create different projects. And in the project, you can have a number of project folders. So mean that you can basically have your 3D model sitting in there, like the InfraWorks model, the Civil 3D model, which any person who has become part of that project team can, based on the level of access that have been given, can access and start working or even downloading different files or design data from wherever they are. So like if it is, this one is the Revit file itself, which if I open it, I can be able to see the bridge that was uploaded from InfraWorks. based on the different number of proposals that were created. So like if this is the detailed proposal that was created from InfraWorks and has been uploaded, you can basically be able to browse and just have a quick view in terms of maybe walking through the different component of the model, doing design queries, and even doing a design reviews by making different markups and just sending for detailed information or request for different detailed information from the project team. So this is the equivalent to the model that I was looking at within InfraWorks on my desktop computer, but it's the same model which has now been uploaded into BIM 360 for design collaboration and coordination of the same. So meaning that I needed not to send maybe whoever I'm working with a design file via mail or whichever file format or way of sharing information, but we just needed to maybe get access to this BIM 360 platform, and then we can now start looking at this model in terms of just basically working at and sharing the design data in real time. So I'm still trying to extract that information because the file is considerably big also sometimes, but it's the same model. It will go to bring in all the roads, all the bridge, the topographic information, plus all the related parts of the same model that I'd opened on my desktop computer, on my desktop software. So, but this was incorporating all component of the model that I had in InfraWorks. But the only part that you want to share within it is only the topography again, as I'm still mentioning. So also you can be able to see on the top right of my screen, and remember I'm on my browser, you'll be able to see that BIM 360 even tracks for me the version. So like right now, this is version number 11 that we are working on. It is on version number 11, but also you have a way that you can even compare the changes in different versions. So like if I want to see what was in version 10, that is not in version 11, or which changes have been made in version 11 that were not in version 10, you can easily do that using BIM 360. But I will not do that because again, that was not my focus, but just giving us an overview that when you use Autodesk BIM 360, you can easily share your infrastructure model and viewing and even querying the design data and the different design component which has been done by your junior engineer. You don't need to even have InfraWorks installed on your computer. So like, for example, you can see this model I'm viewing right now is on a browser. If you could see clearly there, I'm on my web browser. And I've managed to open the same model that I had, showing me everything based on the context of that my project. So like if I wanted to go to the bridge, I'll just zoom a little bit in, then you'll be able to see the bridge where it is. Sorry for that. Just zooming into the bridge. So like, for example, let's say I wanted to have an issue with this part here. So I just want to create a small markup. So maybe I just want my junior engineer to check on the curve on this particular part here. So I'll create a markup. Then I'll just type inside there by creating a text. And maybe I'll just tell him, check on the curve. Check on the curve of this alignment. So basically just an overview of what you can do. So you can see that with BIM 360 docs, you can even do design review, make markups, and just overall just question and query the design which has been shared to you by whoever you're working in that particular project, irrespective of where they are. So like if maybe someone else was sitting in a different part of the office or a different location, you can easily query whatever the designer have done, make changes, and send me the update in terms of what they want me to do. But again, that's not for today. So again, just illustrating what you can be able to do with BIM 360. So I'll just close that and go back. I'll just discard that, go back to the docs within the Civil 3D model. So these are the different Civil 3D DWG files that I have. So again, just an overview. You can see I'm having a number of different Civil 3D DWG files here. And again, each of them with different versions. So like the one I'm going to use to show this one, I've just named it maybe in a bridge topo, is already in version 3. So meaning that maybe when I was in the process of creating it, I had done 2 versions prior to reaching to the one I'm going to illustrate this with. So like if I can open it again, you'll be able to see that it's the same Civil 3D surface, but I can have it either in 2D or 3D again. And I can still query, make markups on it, and create even an issue on it based on the way I'd want to work with it. So like basically be able to see the roads on which, the roads on this particular surface, and even the specific areas where there is a carriageway below the bridge area. You can see that in this case, it's only purely topography. There is no bridge, there is no specific road, but just showing me the specific areas along which the road passes. So if I want to look at it again in 3D, I'll just select 3D model on the right, on the left-hand side of my screen. Then if I select that, it will open the same for me in 3D, but I'm not again interested in looking at it there in 3D. So I'll go back into Civil 3D to illustrate the process of sending that model into BIM 360. So once in Civil 3D, if you're using the latest Civil 3D model, the Civil 3D software version, that is at least version 2019, coming onwards to 2020, again, there's a different tab which was added, dedicated for collaboration. So it's the one that we use to publish this topo surface into BIM 360. Then from BIM 360, we would be able to get it in InfraWorks. So again, this allows you to send your topo surface irrespective of where you are. And every time you publish or make a change into that topo surface and publish it, the one that was already been published in BIM 360 will automatically be updated and a different version created for it. So if you can remember, we're able to see different versions. So there was version 1, version 2, version 3, up to the one that you have up to that particular day that you are going to work on it. So you go into that tab for collaborate. So on your Civil 3 tabs, then you click on publish. So if you click on publish, it basically allows you to select the specific Civil 3D surface that you want to publish and share. So the person you are sharing it with could be the structural engineer who needs to work with it in Revit, or the architect who needs to work with it again in Revit. So the usage may vary. So you can see that I'm having the existing ground, proposed ground, and the FS just basically for finished ground or finished surface. So based on which surface you want to share here, the one that you want to share here is what you select. So like in this case, I'm only interested in publishing the finished surface. So meaning that I'll uncheck the boxes for the proposed and the existing. Then I'll come down here under the specify output file, I'll select the path. So that basically allows me, I don't know if you can still see that small screen which has popped out. It allows me to go and select the specific BIM 360 file location via what we call Autodesk Desktop Connector. So Desktop Connector is equivalent to a shortcut version of your BIM 360 on your desktop, which allows you to directly upload files from your desktop into the online BIM 360. So you can see I'm already having the same files which are in my BIM 360, you can see them here. So like this, if I want to make an update to the one I'm calling webinar bridge topo shared, I'll just look at the one with a similar name here. So the webinar bridge topo, if I click on that there and I click save, it basically means that it will be updating that file which I had saved sometimes back to the one which is up to date that I'm working on right now. So that's the procedure. So just go into your collaborate tab within Civil 3D, at least Civil 3D 2019, and select publish. Publish allows you to share different Civil 3D surfaces via BIM 360. So as you have seen, you click on the 3 dots or under specify output file. It allows you to choose the file path where you want to change it. So basically like the specific BIM 360 account on which you want it published and shared. And remember the account could have different project team, maybe including the specific individual who you want to receive this site information. So then after that, you just click on OK. So if you click OK, it will take like some 3 to 5 seconds based on the speed of your connection, and the service will be up and running in the BIM 360. So like if I click just OK right now here, it will ask me whether I want to proceed with that, because that's basically in terms of the coordinates and the specific surface settings. Like Revit mainly uses surface in using triangulated network, but Civil 3D right now, it is in contour. So sometimes it will be able to ask you whether you want to proceed or not. So I'll just click publish. It takes some few seconds. So if I go online, you'll be able to see my surface will now become version 4. Like when I was reviewing it last time, if you can remember, it was version number 3. But now, right now, if I go back onto it, you should be able to see it reading version number 4, or based on how fast it should have done that. But basically, it's something which will update very soon. I should be able to see version number 4 here. But even if I want to go back to the previous version, I can still be able to share there. So you can see the webinar bridge topo shared. Should be able to see the different versions that I've uploaded and their specific time. So even if I want to change and go back to the previous version of the topo that I'd shared, I'll still be able to access it. But with the time, you'll be able to see version number 4 will start appearing here. We'll renumber it as version number 4 very shortly based on the speed of my connection as of now. So assuming that I've now published it, whoever is interested in using that surface in Revit, I'll assume maybe you could be a structural engineer, which in this case is still me. We'll go into its InfraWorks, into Revit. And once in Revit, again, they just need to link up. So you can see shortly, you can see it's now version number 4. If you can see, I've just made a very short change during this demonstration right now. And you can see within BIM 360, it now shows me that this webinar bridge topo is right now version number 4. And some few seconds ago, it was version number 1. So mean that even if I want to compare which changes have been made between version number 4 and version number 3, I'll just click on compare. And you can be able to see comparison can only be done between 2 different versions. So it automatically selects the 2 latest versions, but I can even compare between version 4 and version number 1. So that's basically in terms of the topographic information, like what are the latest surveying information are we using to do this Civil 3D surface. There could have been some changes between now and the time I last shared my topographic data with the structural engineer or with the architect who's interested in working with it in Revit. So if I click on compare, it will show me those 2 DWGs side by side, and I'll be able to see what's the difference. So like I'll just click on compare right now, and it will load those different DWG files and give me an information in terms of which changes have been made. And right now, I'm very sure I don't expecting any change. So if there was a specific change, I'm very sure I should, let me say, show by color. So you see there is no changes. So I can see the show by color there. What is in version 4 that is not in version 3 is shown by red. And what is in version 3 that is not in version 4 should be shown by blue. So as of now, there is no specific change between the 2 because I just published it without making any change. But if there were real change, I should be able to see each of those in real time. So version compare, version control is something which BIM 360 docs can easily allow you to utilize between the different models that you're working with. So I want to now go into Revit and bring in that topo surface so that you can easily now start seeing our bridge levels in terms of the different elevations that we work with. So you can see right now we do not have that topo. We are just having the bridge model without any surface attached to it. So what you need to do once in Revit, so remember the surface is published by someone else wherever they are, but in this case I'm just doing it because it's not easy to illustrate it by 2 persons during this online show. So what I'll do, I'll go into my Revit, and in Revit there is Insert tab here. But before Insert tab, you're supposed to go into Manage tab. So under Manage tab, basically you're supposed to go into there is the project location. So remember that the models you're working with must be georeferenced. Remember, because you are having a coordinate system for each of them. So you must choose that the topography information that I'm bringing into Revit, which coordinate system should it use? Should it use its own coordinate system or the coordinate system within Revit model? Or should the Revit model extract the coordinate information from the model and the surface and use it? So basically that's what you do when you are in Revit first. You go into the Manage tab, and under the project location, there is the part for coordinate. So you see there are different ways of doing coordinate there. So there is the acquire coordinates, So acquire coordinates basically allows Revit model to acquire coordinates from the shared or linked topo surface. And that's the one I prefer using, because I'm assuming the surveyor have already set their coordinate system, their control points, and what have you that they would want to use even during construction. So I don't want to interfere with it. But sometimes you can also publish your coordinate. Publishing coordinates basically allows InfraWorks to use the current model coordinate such that when we are linking a topo surface, the topo surface will not use its own existing coordinate. It will use the one that the existing Revit model has. So basically, those are the two main important ones, but you can also maybe explore the two last ones. So like in this case, I've already set it to acquire coordinate, meaning that when I'll be linking up that topo surface, it will acquire the coordinate from the topo surface that I'm going to bring in. So once that is done, you go into the Insert tab and you choose on the first, under the links, because you can see you can link a number of different files. In this case, you want to link topography. So click on link topography. On the Insert tab, click on link topography. And that basically allows the software to look for what we call Autodesk Desktop Connector. So I said Desktop Connector, just the shortcut, which allows your desktop software to access cloud models. So the various cloud models that are published within BIM 360, plus the latest version that was published last should now be able to be viewed within Revit and be used within Revit interface. So as you can see, you can choose from different BIM 360 models, projects. So like the specific one I'm using is the one called Xenona Bypass. And you can be able to see even the different versions and the specific topo surfaces that you are interested in using. So like the webinar bridge topo, it is version 4, the one I published some few minutes ago. So if that's what I'm interested in linking in, I'll just select it and click link. So if you click link, it takes a few seconds and it comes in within your Revit. So it's already in. The only thing is that within the view settings that I'm having right now, topography is not set to be visible. So I'll just go into my visibility graphics settings and turn on topography. So if I check on topography, I'll click apply and okay. Basically be able to see that topography has come. So I mean that I can just maybe look at it from this perspective. So I can be able to see that instead of just having the bridge, I'm now having the topography, basically giving me the way the cut and fills along the abutments were done. The piers, you can see that the pier is only visible up to some levels, meaning that there are some levels which are now covered by the ground. So if I want to look at it quite well, I'll just go into an elevation or side view. So I'll just select this particular elevation or side view and be able to see what I'm talking about right now. So initially, we are just able to see the bridge component, but we are not able to see the topo. So like if I now want to just establish elevation very, very fast, like this is what it tells me that this is my pier and the foundation, this is the foundation, and this is the pier. So how deep maybe should that foundation be done? So I can quickly start doing my annotation just to establish those different levels that we are going to work with. So for example, I'll just briefly do annotation. For example, I just want to establish levels. So I want to do spot elevation. So for example, I want to do a spot elevation here. So you can basically see that if I do spot elevation there, it means that if you are to do that right now at the top of at the top surface of that pier foundation, you can see the elevation is reported as 1166.821 meters, or like my default unit is in millimeters. So if you convert that quickly to meters, you'll be able to see. So you can see this is the exact elevation based on the topographic information which was extracted from the surface. So I don't want to do them randomly, or I don't want to be doing them then starting to go back and query the topo surface and start naming them accordingly. So in this case, the information is automatically being extracted from that topo surface that I've added. So the same also, even the top of the carriageway here, I can easily establish its elevation just by clicking on the top there, then automatically labeling it, and be able to see it gives me again the accurate and exact elevation which was used or based on the existing site condition. So that's how easy it is to basically link up the different software via BIM 360. And this is something which is currently missing for those who are using the previous versions or those who do not have BIM 360. You cannot easily achieve or use this if you do not have access to BIM 360, because you basically will be linking up a card which does not automatically give you those updates and does not tell you which version or when was the last update done by the engineer or the surveyor who shared that topographic information with you. So basically that's the basic process that you go through to link up those different software. So basically you see we'll be able to start from InfraWorks, where we did the basic concept of the bridge, we did the topography in terms of the overall roads and how each of those different infrastructure components interact on that site area. Then we sent up the surface into Civil 3D and even customized or worked on it further, after which we uploaded it into BIM 360. Then we are now able to access the same surface into Revit for just overall annotation and establishing of our levels when you're working with the bridge in Revit. So that's what I intended to show today. I want to go further than that because the time maybe is not on my side. And again, it's something which maybe just going further again, we will still be able to explore a lot. So basically, my intention was to just show that step-by-step procedure of getting information from one step to another or from one software to another until you'll be able to reach into this stage. So like if I want to go to the various section of views, I'm very sure the section of views could also be having the same information. Now the topo is not there because I just have to turn on the settings for the topo. So like if I want to add that information for the topo, I'll just go to the visibility settings for this and choose to turn on topography so that I just be able to see the same information side by side with the topography. So you can see this is a side view of my apartment cutting through up to even the girders and the deck. So you can see this is where my surface is and basically be able to see the exact depth. So like if I want to establish the depth of that foundation below the ground, so I'll just say I want to go there and bring it up to this particular level. So like I want to annotate that. I want to bring it up to here. So you can see that's the height up to the pier cap. Then from the top of the foundation up to the level of pier cap, that is that. So you can easily see now annotating and just getting your overall bridge levels becomes very, very easy with respect to the existing and proposed surface that you have extracted from the topography. So basically that's something which I'm very sure will interest many of us. It's because it's something which usually takes us a lot of time to establish such working levels which can be used for construction or just develop construction layout. The same also if I want to establish a coordinate, maybe a random control point, I'll just say spot coordinates. I want to maybe establish a coordinate at this end here. You can easily get the coordinate for that particular point and also the coordinate for this particular point easily. And the coordinates are now being extracted just because our model is georeferenced and the fact that we're able to bring in the actual topographic data that was used to do the bridge in Revit, in InfraWorks. And remember, each of them are geo-referenced. So that's what I intended to show today. So I'll just maybe pause shortly to take some few questions that you might be having for me before we stop. Zoe?
Hi, Elijah. Thank you very much. Yes, we have two questions from Errol Becker. The first question is, have you experienced problems with the project base point moving when reloading an updated topo surface? We tried this method and noticed the updated topo surface through the project base point causing inaccuracies.
Sorry, is that question on the chat? Let me read it. The experience problem in the project-based point moving. Okay, I think that usually happens if you do not fix your site reference point within Revit. So the first thing you should do before you start bringing in any topographic information into Revit, you should first start by reporting a coordinate of a specific point. Then use that specific point as your reference point within Revit, such that every time you are making updates, it should be your point of reference. Because if you make a change, or maybe you could have maybe changed some specific surveying point within Revit, within InfraWorks, sorry, or Civil 3D. When you try to make an update within your bridge in Revit, it usually tends to reorientate, meaning that it can either maybe shift towards north or towards south, based on the differences that you are trying to incorporate at that particular point in time. So what you should be able to do every time when you're starting your bridge model within Revit, first start by reporting a coordinate for a specific point, just by going to the specific, to the workflow, the procedure is shown. On the Manage tab, go to Project Location, and he said, do not acquire or report or use coordinate, but first start by reporting a coordinate for a specific point, and use that coordinate, that point as your reference point within Revit. Then every time you are making any update, it should be rotating or referencing that specific point you started with within Revit itself first. And therefore it allows you to even control and be able to even view the changes that you are making with respect to the changes that you are made within either Civil 3D surface or infra surface that you are importing. Or maybe if I didn't answer that compressively, maybe we can schedule a separate time with you, maybe in the course of the week if you're available. Then we'll look at that on a step-by-step basis with you as when we be able to get time. Then.
Thanks, Elijah. The second question we have from Errol Bakker: are you able to export underground works, in other words, stormwater pipes from civils to Revit using this feature yet?
Sorry, this procedure only works for topo. This procedure only works for topographic surface between Civil 3D and Revit. And Revit, as of now, I don't think there's a way of sending such underground stormwater pipes into Revit. And again, the assumption is that I don't know why one would be interested in sending them into Revit, because these are more of infrastructure elements, which I don't think Revit has any functionality of maybe doing anything to do with them further. Because maybe the thought would be maybe to do with things like the MEP pipes. But for stormwater, which is purely infrastructure, they will totally remain in Civil 3D. You can't, unless you change them to another file format, which I've not yet experienced to know how possible that would be. But as of now, I noticed it's not possible to send it into Revit through this process I've just shown.
Thank you. A question from Claudia: how can we measure the distance from a component to the existing ground level?
From a component, Revit component to the existing ground level. Okay, that I didn't know. I don't know if I can try it out, because I think it should just work with the normal way of annotation or use measure. Just you can either annotate or use the normal measure tool within Revit, and you can easily measure and know if there is any difference. Like for example, the difference between the carriage, the bottom of the girder up to the top of the road on which you are doing that particular bridge. So I think you just use the normal measure, and again, or you can annotate it using the normal Revit annotation tools. But again, if that doesn't work for you, you can just, again, we can contact you after this to be able to see what exactly was making yours not happening. So again, the last I think is on the cost of BM360 docs. So the cost varies again. So this depends on which part of the continent you are. you should be able to maybe contact our local resellers, or Zoe will provide you with more details on how to get the exact costs and pricing for the same.
If there are any questions from any of our other attendees, please feel free to ask, and Elijah is happy to answer them. If there are any questions, please use the Q&A. Thank you. Great, I don't think there are any more questions. Thank you very much for all our attendees today joining us on the webinar. I will be sending out an email to all the participants with a recording to the webinar for your use at a later stage. If you'd like to watch it again, you will receive an email from me by the end of the week. Thank you all once again for attending. Thank you, Elijah.
Thank you, Zoe. Thank you, everyone, for attending. Have a good afternoon.
Thank you. Have a good day further.